Bash scripts can use arrays, dictionaries, sat, read-only variables, int-only variables, and more. Let's get on with it. So we'll start with arrays. First, the simple method. Let's just put in the elements in parentheses. So with Alice, Bob, Eve, and Chuck, we have 4 elements. Let's see different forms of using it. So if you use just users variable, when we use asterisk variable, we can also use at instead of asterisk. So when we use just users, it's Alice. With index, we get relevant values, and with asterisk or at, we get all the values. Now we'll see how we can simply iterate over these values using for. So remember using at and enclosing them within curly braces, and we'll be able to iterate over them. Now we can also append to this array. All we have to do is plus equal to, and within parentheses more elements, and we have more values. Now we can have just the count using hash users. It's showing 5 because I missed putting at. I'm showing the current 7, and this is actually an associative kind of array. So if we use exclamation mark, we get the indices. Now we'll show how to declare it using declare, a bash available utility. So this is explicitly declaring it as an associative array. That's what we get when we use -a with declare. As you see, we have Alice, Chuck, Eve, Bob. Now if we want to add more, we can simply define it like this. And we have the similar effect, same run, declaring arrays with declare. Now get on with dictionaries. Here we'll be using the same associative array, but we'll be using actual string based keys instead of indexes. So okay, HTTP 200, client or HTTP 404, server error for 500. Let's have these, and since it's similar associative array, we can use same kind of bits for the count with hash, the indices will be the keys. So for keys iteration, we need exclamation mark. For values, without exclamation mark. So when we run it, we get the relevant values, and the iteration over it is same as well. So for the element in the variable and then the task, I'll need to correct the app code. It will have to be with at and within the curly dollar, and I'm iterating over the keys, so exclamation mark as well. The output is as wanted. So let's now move on to set. So sets are primarily kind of lists where there's no duplicate entry. So we'll be using the associative array. It's just that for the elements, the values in set, we'll be using the keys, and the value will keep true for all. So going ahead, I'll show how that is relevant in our case. So admin, guest, and John Doe are the elements of set. Let's simply first print out all the elements using the key with exclamation mark. We have all the elements here. Now the relevance of true is we can use it to see if a particular element is part of the set or not. So if John Doe exists, it will echo the user John Doe exists, and if the key in it doesn't exist, it won't print it. So since we don't have a nobody is equal to true defined, it shouldn't say user nobody exists, and it does as intended. And let's check for the duplicacy as well. It's only prints John Doe once. Now for more, first we'll check the read-only type of variables. So if we provide -r, it will set the declared variable as read-only. So once assigned, we won't be able to change the values of, say, Google 8888. So anywhere further in this program, those values wouldn't be allowed to change. We won't even be able to allow to add a new key val. So here, once we are adding local a new value, so let's echo the DNS before it and after, and let's see what we get. The error is as intended. Since DNS is a read-only variable, we are not adding more. Now, declare also allows us to have variables where the value will automatically be in uppercase or lowercase. So -l for lowercase, -u for uppercase. So when we provide the same string that is a mix of uppercase and lowercase to low message and upper message, they will have a different effect because declared with -l and -u. So let's echo them and see the impact. Now echo all lowercase and all uppercase. Now let's clear it and see -i for integer only variables. So exit code, say we don't want any other variable, just 0, 1, 2 kind of variables. So this should be 10. It also supports minus values, so -10 would be -10. But any other values would be as 0. So if we say give it a, run it, that'll be 0. Now let's clean it up. And with -small a, it gets, instead of associative error, we get indexed array. So say we have provided 0, 1, 2 keys with different values. In a -A, if we say do status -1 and any value, what will happen is it will keep that key and it will have 4 elements. So -1, undef, 0, okay, 1, won, 2, error. Now let's check, we have the base bit. Yeah. So, but with associative array that will work. With indexed array, what will happen is if we assign -1 is equal to undef, it will actually go back and overwrite. For -1, it will overwrite 2. For -2, it will overwrite 1. And for -3, it will overwrite 0. And since it only has 3 elements, if we do -4, that will be an error. So for -2, let's first check for -1, 2, 3. And we'll assign it values so that we can check the impact. -3 was 0. So this works as intended. Now let's try assigning 1 for -4, where we don't have any at that index. So it should give it an error instead. And that's what we get.